Okay, these are our lesson 6.2, 6.3 notes. We are solving systems of equations using substitution and elimination, this time instead of graphing. So we've solved systems of equations and inequalities by graphing up till this point. Now we're going to learn about substitution and elimination, and then in the future we're actually going to do substitution and elimination using multiplication and other factors when we do it. So the first thing we have to remember is that when the system of equations has one solution, meaning they cross in one place, that solution is a coordinate. It's not just an x equals 2 or a y equals 3, it's an xy coordinate. So when you solve for x or y, you need to substitute it back into one of the original equations to get the missing value of the coordinate, and we'll be practicing that today. So we're going to start with substitution and elimination instead of doing one or the other, because we always have to ask ourselves the question whether we're going to do substitution or elimination, which one's better for us. Okay, so Ms. Parker and I will be teaching you that we always want to do the easiest way, but you can do any way that you like, as long as you do it with fidelity. So when we use substitution, we're going to use it when one of the equations is solved for a variable or value that can easily be replaced into the other equation. So if I see one of them like y equals x plus 3, and then the other one says 3x plus 2y equals 11, well, this one's already solved for y, so it'll be real easy to substitute the value of y into this equation, and we'll do that in just a minute. The next one will be substitution when both equations equal the same variable or value, so they can be set equal to each other. So if they're both set equal to y, well, if this equals y and this equals y, then they equal each other, and that's one of our properties. If you remember, that's the transitive property. If a equals b and a equals c, then b equals c. Same thing here. So if 2x equals this value and 2x equals this value, then if both of them equal 2x, then they're equal to each other, and we'll solve that as well. Elimination comes into play when we can eliminate one of the variables, because when we add or subtract the two equations together, one of the variables will drop out, because that's our whole goal, is for one of the variables to go away so we can solve for the other one, since we can't solve if we have an x and a y, but I can solve for x or y if I only have x or y. So in this case, I've got negative 2x plus y equals negative 6, and we've got positive 2x plus 3y equals negative 2. So when they line up like this, our x terms, our y terms, the equal sign, and the constant here, we can easily add these together and something will drop out, and we'll work through that one in just a second. So let's go back to the first substitution, where I have something that I can substitute in for y here. So everywhere I see a y in the second equation, I'm going to plug in x plus 3. So we're going to plug that right into the second equation. Notice it's just written down here. So this is 3x plus 2y equals 11, only we left the y space wide because we plugged in x plus 3 instead of the y. So now I do my distribution of the two. So I get 3x plus 2x plus 6 equals 11. Then I combine my like terms because 3x and 2x are on the same side of my equal sign, and so I get 5x plus 6 equals 11. And now I'm going to solve for x. So I'm going to subtract 6 from both sides. See if I have enough room here. So I'm going to subtract 6. So I get 5x, and these canceled here, equals 5, right? I'm sorry, I'm a little bit off. Then we're going to divide both sides by 5. Divide by 5. And we get x equals 1. So x equals 1. And then we're going to plug it back in, because remember, substitute the value you solved for back into an original equation to get your missing value. We are not done here. The answer is not x equals 1, because I have got to find both values in order to solve the system. So I'm going to plug it back into this original one since it's easy. So I'm going to get y equals, and instead of x, I'm going to plug in 1 since I know that value now. So 1 plus 3. And so I get y equals 4. So my actual answer to this equation, or this system of equations, is 1, 4. So that's the point at which these two linear equations cross. So 1, 4 is a solution for both of those. So that is one way to do substitution. Excuse me. So now the next one is when both equations equal the same variable or value so that they can be set to equal to each other. It's the same thing, noticing that my y drops out. So now I've just got an equation with variables on both sides. So I'm going to subtract 2x, and I get 2x minus 1 equals negative 3. Don't forget that negative goes with that 3. So these cross out. And then I'm going to add 1. And so I get 2x equals negative 2. And so x equals negative 1. If I divided both sides by 2, that's how I get the negative 1. So x equals negative 1 here. And then I'm going to take that negative 1 and plug it back into either one of these. It does not matter. And in this case, I'm just going to take the second one just to show you. So I'm going to get y equals negative, or I'm sorry, not negative, it's 2 times negative 1 minus 3. So I get y equals negative 2 minus 3, which equals y equals negative 5. So I get negative 1, negative 5. Okay, then the next one, same thing. Since they both equal 2x, I can set these two values equal to each other. I'm going to solve for y this time instead of x. So I'm going to add 3y. So I get 4y minus 1 equals 3. Add 1. My pen's not cooperating well, but that's okay. 4y equals 4. And so y equals 1. Got a lot of 1s and negative 1s here. So y equals 1. Again, I'm going to plug it back into an original problem. So I'm going to go ahead and do the first one because it doesn't matter. So I get 2x equals 1 minus 1, right? Because I plugged in that value of 1 here. So 1 minus 1 is 0, so 2x equals 0. And if I divide both sides by 2, that means x equals 0. So this will be 1, or I'm sorry, not 1, 0, comma 1, because y is the one value and x is 0. And then this one, the last example, this is elimination. So again, it's when both equations are in standard form and the x or the y term will eliminate when adding or subtracting. Well, in this case, we're going to add because a negative 2 plus a positive 2 will be 0. So these will cancel like this. Y plus 3y is 4y. Negative 6 plus negative 2 is negative 8. I divide by 4 on both sides to get y by itself. So I get y equals negative 2. So if y is negative 2, I'm going to plug it back into one of the original equations. I'm going to pick the first one just because it doesn't matter. You could pick the second one. So I get negative 2x and then plus, and I'm going to put parentheses. I like to do that for whatever I substitute. Negative 2 equals negative 6. And then I solve as normal. So I'm going to add 2. So I get negative 2x equals negative 4. So that means x equals 2. And so, because I divide both sides by negative 2, you guys are solving by now, so we shouldn't really have to work over that. And so the answer here is 2, negative 2.